We're going to go ahead and look at lesson 5.6. There will be another video for developing these identities. We are just going to be using them today. So we're going to scroll down here. Here are the 4 different sum and difference identities. The word sum and difference just tells us if we're adding or subtracting 2 angles. So we would call the first one the cosine difference identity. The second one we would call the cosine sum identity, and then the sine difference identity and the sine sum identity. And we notice we have a few formulas there, and you see what those things are equal to. And again, they will be proved in another video. So what we're going to do here is we're going to use these to help us find some exact values of some other trig functions that aren't on the chart that we've learned about before. So we're familiar with finding sine, cosine, and tangent of pi over 6, pi over 4, pi over 3, and pi over 2, and then other ones that are related to those angles. I guess we can throw in 0 radians also. But now we have a cosine of pi over 12 here in our example, which is not one of the ones we know, but we still want to find the exact value. So what we end up doing, we end up using the sum or difference identities along with sine, cosine, or tangent of some of the angles that we are already familiar with. So what you need to understand here and use are fractions. And hopefully you'll get better at these. You are familiar with fractions already, so you should be able to pick up on this. But pi over 12, we want to somehow get pi over 12 using, and I should have written them here, pi over 6, pi over 4, pi over 3, pi over 2, although we don't really use pi over 2 much for anything that I remember. We can even use the ones in all of the other quadrants, which we'll have to use at some time, to 2 pi over 3, 3 pi over 4, 5 pi over 6, and then we have 7 pi over 6, 5 pi over 4, 4 pi over 3, and then onto the 4th quadrant, we have 5 pi over 3, what do we want? 7 pi over 4, and 11 pi over 6. So these are from the 1st quadrant, 2nd quadrant, 3rd quadrant, and 4th quadrant, which really isn't too important, except for your different signs, as in positive or negative signs there. So what we want to do is we want to figure out what is pi over 12 using some of these fractions that we're familiar with. And so when I was saying you need to know about fractions, realize all of these can be written as something over 12, so 2 pi over 12. And this would be, if you got a common denominator, pi over 4 is 3 pi over 12. And this is 4 pi over 12. And we could go all the way down the line and do all those over 12. And that's what we use most, is those things in with a denominator of 12. But now that we know that, we can realize we can get 1 pi over 12 here. We have a pi over 12 or a 1 pi over 12. We can do that using subtraction. And we can say that cosine of pi over 12 is really, and we have a few options already, we can do 3 pi over 12. So this one, minus 2 pi over 12. That gives us 1 pi over 12. And so what we do is we rewrite the pi over 12, or in the next example, 5 pi over 12. We rewrite that as a sum or difference of some of these ones that we're familiar with already. So I'm going to erase this so it's out of our way. And now what we do is we simply realize, hey, this is a difference. We're subtracting. And so we come up and we look at our difference identity. And as you get better and better at this, hopefully you'll start remembering these, but we're going to use this identity right here. It's the cosine difference identity, where x, in our example here, x is going to be 3 pi over 12, which in what we're familiar with, if we reduce that, that's pi over 4. And then y, that is the 2 pi over 12 from our problem below, which is simply pi over 6. So we can think of this, and maybe we'll write it that way. I'll actually come off to the side here. We're going to say this is pi over 4 minus pi over 6. And again, this, from our formula above, we're going to put pi over 4 in for x, and we're going to put pi over 6 in for y. So now we're just going to start plugging in. So we'll use, again, this highlighted formula up here. So we have cosine of x, which is pi over 4. So again, I am just plugging into this formula at the top. Cosine of pi over 4 times cosine of pi over 6. And then we have a plus sign, and then we have sine of x, which is pi over 4, and sine of y, which is pi over 6. And hopefully you are still familiar with what all these things are equal to. They're all in the first quadrant, so they are all positive. So cosine of pi over 4 is root 2 over 2. We'll go ahead and make this larger for now. Cosine of pi over 6 is root 3 over 2. Plus sine of pi over 2 is root 2 over 2. And sine of pi over 6 is 1/2. And so simplifying here, we get root 6 over 4 plus root 2 over 4. And we actually have a common denominator there. So we can say this is root 6 plus root 2 over 4. We obviously cannot combine the root 6 plus the root 2. They're not like radicals, so you can't add them. A way to check our answer, if you have a calculator, so we wanted to find the exact value, which we have. You could type cosine of pi over 12 in your calculator. You could type this in your calculator, and they should give you the same thing. All right, moving on to the next example. We have sine of 5 pi over 12. Well, 5 pi over 12, we want to figure out how can we write 5 pi over 12 as a sum or difference of some of the angles that we are already familiar with. And actually, we're going to use the same ones because pi over 6 is 2 pi over 12, and pi over 4, maybe I should write up here, is 3 pi over 12, and that adds to equal 5 pi over 12. So again, make sure you're familiar with fractions and writing things as with a denominator of 12. So we can write this as we're going to do pi over 6 plus pi over 4. And once again, we can do that because this is 2 pi over 12 plus 3 pi over 12 gives us the 5 pi over 12. And so now what we're going to do is we're just going to use our formula again. So this is going to be equal to, and once again, so this will be our x, and this will be y, and we're going to plug in. So now we're going to use the sum identity for sine. So let's see if we can fit this all on the same screen. Actually, it's this bottom one right here. So let's we're going to use this one. This is the sum identity for sine. And so we see we have sine of x times cosine of y plus cosine of x sine of y. So we're just going to use that formula and plug in our values for x and y. So this is sine of x, which is pi over 6, cosine y, which is the pi over 4. And we have a plus sign in between those two terms, and then we have cosine of x, so cosine of pi over 6 times sine of y, which is sine of pi over 4. And we go ahead and simplify. Sine of pi over 6 is 1/2. Cosine of pi over 4 is root 2 over 2 plus root 3 over 2 times root 2 over 2, which gives us root 2 over 4 plus root 6 over 4, which actually is exactly what we got for the last one, which seems strange, maybe, but it is correct. Now, not all of our answers will not be root 2 plus root 6 over 4. The reason those two are the same is because if you think of a right triangle, that's a 90 degrees. This might be 5 pi over 12, and this is 1 pi over 12. And so sine of the one is the same as cosine of the other. So, and there's actually an identity for that we'll talk about later. So that's one way you'll see these. We didn't get into these other ones for our examples, but you will. And just remember that in the first quadrant, all trig ratios are positive. In the second quadrant, just sine is positive. So all are positive, sine's positive. Tangent is positive, and then in the fourth quadrant, cosine is positive and the others are negative. So you will have to use that in some of these. Okay, another type of question that we will see, something like this. So we're going to use those identities again, but in a little bit different way. And we'll actually use some of the other identities as we work through here. So this says if cosine x equals 5/13 and cosine of y equals 4/5, where x is in the first quadrant and y is in the fourth quadrant. So that's important. Y is in the fourth quadrant. So in the fourth quadrant, remember, cosine will be positive, but sine and tangent are negative. So we may or may not have to use that. Evaluate the following. Well, the first one, A, really has nothing to do with what we're learning today. We could actually find this a couple different ways, but what I'm going to do is just review the Pythagorean identities, and we can realize that we know we have cosine of x. So is there a relationship that we know, the trig identities that relate sine and cosine, and we just learned the Pythagorean identities that we know that sine squared of x plus cosine squared of x is equal to 1. It's a very important Pythagorean identity. Well, we actually know cosine of x, so we can say sine squared plus cosine of x is 5/13, so cosine squared of x is 5/13 squared equals 1. And working our way through here, this is 25 over 169. And thinking ahead, I'm going to realize I'm going to solve for this. So I'm going to go ahead and write this as 169 over 169 because I'm going to want a common denominator. I will then subtract 25 169ths from both sides. I may not have left enough room on your paper to do this. So we have sine squared is equal to 144 over 169. And then we take the square root of both sides. So x, we would normally put plus or minus the square root. Well, actually, the square root of 144 over 169 is 12 over 13. So we're taking the square root of both sides. Let me write that in there. We're going to go ahead and take the square root of both sides. We do plus or minus. So sine of x, I also didn't write that correctly. This is sine of x equals plus or minus 12/13. However, it tells us x is in the first quadrant, so sine is positive in the first quadrant. So actually, in our case, sine of x is equal to positive 12/13. I will take a quick second to tell you something here. If you know your Pythagorean triples, if you knew that 5, 12, 13 was a Pythagorean triple, and you saw cosine was 5/13, that's your adjacent and your hypotenuse, then the other leg had to be 12 because of that Pythagorean triple. So it's good to know your Pythagorean triples. All right, moving on to part B, sine of y. Well, we can do the exact same thing. We can think sine squared of y plus cosine squared of y is equal to 1. By the way, before we do this, I'm going to work through it. But if you know a Pythagorean triple that has 5 as a hypotenuse and 4 as a leg, you might be able to quickly figure out what sine of y is. So we'll get to that. And we're just going to do the same work here. So sine squared of y plus cosine is 4/5. So we want 4/5 squared equals 1. Sine squared of y plus 16/25 equals, I'll go ahead and write this as 25/25 because I'm going to subtract. I'm not going to show the work here. I'm going to subtract 16/25 from both sides. So sine squared of y, 25 minus 16 is 9/25. We're going to go ahead and take the square root of both sides. So sine of y equals plus or minus 3/5. And I mentioned before that y is in the fourth quadrant, so sine and tangent are negative. So in this case, sine has to be negative. So sine of y equals negative 3/5. All right, so that's the answer to that one. As mentioned before, if you knew that 3, 4, 5 is a Pythagorean triple, you could have realized that it was 3/5. That would not have told you about the negative, so you have to be aware of what quadrant you're speaking of. So that didn't use our sum or difference identities at all, but now we are going to do that. So on part C, we want to find the cosine of x minus y. X minus y. So I'm really going to have to scroll up here and make this small if we want to see it all at once. Maybe we'll just copy it down here. Now, as you get used to seeing these and using these, you'll probably start to even memorize them just by using them. But it's the one at the top there that's highlighted and circled in red. That's the cosine difference identity. So it's cosine x, cosine y, plus sine x, sine y. And I'll just write it here, cosine x, cosine y, plus sine x, sine y. Well, from what we just, so I'm going to zoom out enough to see our work here. We know all these things. We know cosine x. That was in our directions. We know cosine y. That was in our directions. We found sine x down here. And we found sine y. So all we have to do is plug in. I'm going to undo that because I want to be able to see this a little better. But here we have cosine x. Now, a lot of people make this mistake, and please don't make this mistake. They see cosine x and they look here, and for some reason, they'll write cosine of 5/13. That is not what that says. This says cosine of x, slide over and erase all this mess, cosine of x equals 5/13. So do not put cosine of 5/13. I say that, but some of you probably still will. I hope you prove me wrong. So this is 5/13, because that's what the cosine of x equals. Cosine of y is 4/5. plus sine of x, it's down here, that's 12/13, and sine of y is negative 3/5. Now we're just going to simplify some fractions. In this first group, we could cancel the 5s, but looking ahead a little bit, we're probably going to have to add some fractions, so I'm not going to cancel the 5s. So we have 20 over 65 plus negative 36 over 65. Combine those. 20 minus 36 is negative 16 over 65. And that is our answer for cosine of x minus y. Well, now we can do sine of x minus y. Well, we could have before. I'm going to go ahead and use the Pythagorean, the sum and difference again, but we could use Pythagorean because we could do sine squared plus cosine squared, which we found here, is equal to 1, and that would work out just as well. So it's interesting we can find those a few different ways. But let's go ahead and practice our difference identities. So again, make sure you get to know these well. Here's our difference identity for sine. Sine x cosine y minus cosine x sine y. So we are doing this one. Sine x cosine y, sine x cosine y minus cosine x sine y. And we have all these values from the directions or from part A or B. So let's get all those on the screen. Sine x, kind of the bottom left there, sine of x is 12/13. Cosine y, that's from the directions, that was 4/5. Minus sine, cosine x, also from the directions, so 5/13. And sine of y, that was from part B, that was negative 3/5. And so we have 48 over 13 times 5 is 65. We'll actually have a plus because we have minus and negative, so it's going to be plus 15 over 65. And we add those together. 48 plus 15 is 63 over 65. And that's how you do those. So we have two different types of questions that we worked with when dealing with the sum and difference identities. We could find sine, cosine of different angles using the sum or difference identities, and then given certain information in the second example, we could find some other trig values. You might have to find tangent in some of these. Make sure you know that tangent of any angle is actually always equal to sine of that angle over cosine of that angle.